we're going to do today is we're still staying in less than 1.6. But what I want us to do is I want us in first, every row is a problem, are problems on here, and the problems are, they kind of like imitate each other. You know how to solve the ones on the left actually pretty comfortably by now, right? When there's only one variable involved, you should be really comfortable with solving those equations. But then when they throw more than one variable in, some of us are like, that's what we are like, oh no, I don't know what to do now. But yet we really need to have the same thought processes. So tell me, what's the thought process over here in this one, 5 equals a minus 3? If we're supposed to solve it for a, what's the first thing our brain should tell us to do? Devin?
Add 3.
Add 3. We need the a alone, don't we? So we're going to add 3, and it didn't even take you very long to come up with that, did it? But the thing is what's confusing over here, we get a nice clean value for a, don't we? It's 8. So we're used to getting a numerical answer, but in reality, when we're solving these equations that have more than one variable involved, anybody discover what types of equations these are called when they have more than one variable in them? Anybody go dig into that lesson any more on their own? Okay, well then you better find it in your book. Get it, find it. What type of an equation is a equals b minus c called? You already got it, Devin?
Yep.
What is it?
A literal equation.
A literal equation. Everybody find that. A literal equation. When you have an equation with 2 or more variables in it, we call it a literal equation. So when we have literal equations, we don't get these nice clean-cut numerical answers. Devin, could you tell them out on what page to find that out?
Page 50, it's right below, check it out 2.
Okay, so it's always about in the middle of the page on page 50. Okay, so literal equations, when we have 2 or more variables involved. So when we're solving a literal equation, oftentimes also called a formula because it's a rule for something, when we're solving a literal equation, we're just going to have the same thought process. If I'm solving a equals b minus c, for b, I need to get b alone. So what am I going to do to both sides? Andrew? Add c. I need to get b alone, so I'm going to undo that subtracting of c. I'm going to add it. And only problem is now I can't actually add a and c, can I? Because what? Because what?
No.
They're not like terms, so instead I have to write it like this. And that's as good as it gets. That's it. That's the answer, right? Okay. So again, we just have the same thought process, but we just have more variables involved. So let's go over here to 6 equals negative 2x. What's happening? If we're solving that for x, we got to zero in on the side that x is on, and we have to say what's happening on that side. So what's happening on that side? It's being multiplied by negative 2. So what are we going to do? We're going to divide by negative 2. Doesn't take us long to make that decision. We decide, you know what, I need to divide by negative 2. So 6 gets divided by negative 2, negative 2x gets divided by negative 2. So what's our solution?
Negative 3 equals x.
Negative 3 equals x, also known as x equals negative 3, right?
Yeah.
Okay? Well, then when we move over here to solve this one for r, it's really, what's happening in that one? We have to get I alone. It's being multiplied by I, so we need to divide by I. So we just take IR and divide it by I, take B and divide it by I, and say, well, these guys cancel out, and I get R alone, which was the goal. Can B be divided by I? No. So we just leave it B over I, don't we? So again, as easy as right now this seems, what am I trying to get you to understand about these solving literal equations? They're just the same as the solving equations with one variable in them. You still have the same process to go through. You need to get the variable alone. So what do we do in this one over here where we have x over 5 equal to 3? What do we have to do to that one? Shay? Multiply both sides by 5 because x is being divided by 5. So I take both sides times 5. And x is equal to 15. Well, look at right next door. We have w equals a over L, and we need to solve it for a. So what are we going to do to both sides? Austin?
Multiply by L.
We're going to multiply by L. We need a alone. A is being divided by L, so we're going to multiply by L. Good multiplication done, a little low there. So same thought. I need A alone. A is being divided by L. How do I undo divided by L? I multiply by L. So my answer is going to be A equals, I can move the A to the other side, right? Yeah. And I have L, capital W. Again, remember, what are we going to do? If they're already uppercase, we're going to leave them uppercase. If they're lowercase, we're going to leave them lowercase. That's a really important thing that we have to make sure that we do. Okay. So questions. Let's talk about, we introduced really anything new. No, we really didn't. Okay, so what are we going to do in this next one? 7x plus 3 equals 10. What's going to be our first move, class? Subtract 3. Yep, subtract 3 from both sides because we're zeroing in on that 7x and saying eventually I need that x alone, so I'm going to first get rid of the 3. And I now have 7x alone. And 10 take away 3 is? 7.
Now divide 7 by both for both sides.
Okay, but we don't divide from, we're going to divide both sides by 7. Yeah, we're just going to learn how to say it right as all. 7x divided by 7, and 7 divided by 7?
1.
X equals 1. X equals 1. Okay, so if we're supposed to solve ax plus c equals capital R for x, what's our first thought process? I need to get what alone first? Shay, what do we need to get alone first? The ax, right? We need the ax term by itself. So what are we going to do? We're going to subtract c on both sides. Now ax is by itself, and can little c really be subtracted from big R? No. Does order matter in subtraction?
No.
Good.
So R has to be first. Even if C is before R in the alphabet, and algebra also likes alphabetizing, we can't ruin the rules of operations though. Subtraction's fussy. What are we going to do next? Well, yeah, we're going to divide by A. So AX is going to get divided by A. R, capital R, little c is going to get divided by A. Because our goal is, again, get x alone. X is being multiplied by small a. So we have x equals yeah, we just don't get a nice clean cut numerical answer, but we get an answer that is really what? Just another way of writing the equation. It's just another name for the equation. Just like 2 plus 3 is another name for 3 plus 2 is another name for 5, right? Yeah, it's not a trick question. So we can rename things all the time. Okay, I want you to solve the next one then. This one over here. I just want you to solve 13 equals 15 minus 4x. These sometimes did not go so well on some people's papers and or assessments. So let's see if we do this right, first of all. Okay, AJ, what was your first move?
Subtract 15 from both sides.
Okay, why are we subtracting 15?
Because 15 is a positive number.
Okay, and he's right. We do subtract 15, but here's what happened a lot when I was correcting papers, whether they were that lesson 1.4 checkup or they were your quiz, whatever they were, where I was trying to make sure you understood this. A apparently some students think we can read this as 4x minus 15. That 15 is being subtracted. Can we read from right to left with subtraction?
No.
No, we have to read left to right, don't we? So in reality, we have a positive 15. To undo that, take 15 away from it, right? So we have, what's over here? 13 take away 15. Negative 2. What do we have left on? Negative 4x. Now that subtraction sign becomes part of the 4x, doesn't it? So if we change this to add the opposite, now we could read it backwards, and we can clearly see we have a negative 4x going on over here. And now what will we do to both sides? Divide by negative 4. Okay, so we'll take negative 2 and divide it by negative 4. We'll take negative 4x and divide it by negative 4. This also sometimes creates an issue.
Negative.
What's a negative
One
divided
half.
by a negative?
Positive.
A positive. And 2 divided by 4?
1/2.
1/2. Yeah, we can't really take any 4s out of 2, can we? So we would say 1/2. We can take a half of 4 out of 2. There's our answer. And again, we have to be really careful with those negatives when we're multiplying and dividing, adding, subtracting, whatever it is we're doing. Okay, well, look at this equation over here. Does it really, we need to solve it for p. Well, p is in the same location as x is over on our other side, so we should be able to just follow the same process, right? Okay, what are we going to do first? Subtract w from both sides. And now we're going to have h minus w, because we can't make that hw, can we?
No.
What does hw mean?
You're taking h multiplying 2 w.
Yeah, now we're multiplying. If we stick them beside each other, now we're multiplying. We can't multiply, we're supposed to be subtracting. What do we have on the other side?
Negative 3.
Negative 3p. Okay, now what?
Divide by negative 3.
Divide by negative 3, just like we did over there. We divided by negative 4 because that's what x was being multiplied by. Over here, p is being multiplied by negative 3, so we're going to divide by negative 3. Okay, so now these negative 3's cancel. What about that other side? Anything we can do there? Okay, it stays how it is, but this is not how you're going to see the answer in the answer bank most likely. So we're going to have to do something to it. What do you think they might want us to do with that? Because you're like, you get this answer, but you look at the multiple choice answer bank, and you're like, well, mine isn't in there, but it's kind of close to this one, so you just say, well, I guess I'll just guess. That isn't what I want you doing. I don't want you to just hope that your answer is really the same as you want, the one you see there. I want you to make sure. So what did I tell you we can do with negative signs in fractions? We can change subtraction to add the opposite, but what about negatives within a fraction? So what if we had this as our answer instead? What if we had 1 over negative 3? What could we do?
You could give it to the
Numerator.
You could give it to the numerator, or you could even,
just put it in.
you just put it right up front. You make the fraction itself negative. So that's what we're going to do with this. We are going to bring that negative sign because it's not remember when there's no addition or subtraction going on, you don't have to worry about messing things up. So we're going to bring that negative sign, oops, I didn't do it then. We're going to bring that negative sign out front. We're going to say that we have negative h minus w over positive 3. That's what our little p is equal to. That's going to be our answer. That's most likely how you would see it in an answer bank. Now there is another way that we could see that answer given. Very possible that you guys just said you could give the negative sign instead to the numerator. Remember if somebody said that? Was that you, Devin? Somebody said give it to the numerator, you can do that. But if we give it to the numerator, we have to give it to both pieces upstairs because there's a subtraction problem going on. So we would give it to the h, we would give it to the negative w, and now this is what our answer would look like. So there's a possible, they might even do that with it. I mean, we have to know what are the options of what can be done so that when your answer doesn't match, you're convinced that it's really the same as another name given in the answer bank, okay? I'm gonna guess that most likely the one I have circled would be the way they would show it. But again, it's possible there's the other way. Okay, I have a challenge one here for us. Okay, let's start over here. Solve for x. I don't know that we had anything like this when we were solving these types of equations. So let's see if we can figure out what we should do. What should we do in that one, do you think? 8 equals 96 over 3x. What might be a good place to start, Austin?
Multiply both sides by 96.
Multiply both sides by 96. Okay, what would be our reason for multiplying by 96?
96 is being divided by 3x.
Okay, well, if 96 is being divided by 3x, you're telling me that we're trying to get rid of the 96, and 96 is already, so if we divide by 96, is that what you said, right, or multiply? Multiply. So you're trying to do something with 96 and you're not even trying to undo it. So I'm thinking that we probably don't want to mess around with the 96, especially multiply by it, okay? Now, if you would multiply both sides, that would be totally cool. But then in the end, we're just going to have to simplify. So I'm thinking we're going to leave that. Devin.
You could multiply both sides by 3x.
Well, yeah, because what did I say on Friday?
If it's all together in one, you can take it times everything.
And when we have a denominator, do we want to get rid of it? Do we want to get that out?
Yes.
I said on Friday, when there's a denominator, get it out. So let's get that 3x out of a denominator first of all. So yes, we're going to take both sides times 3x. Both sides times 3x first of all. So we can get that 3x to cancel out of that, that's no longer under that 96. So these guys, now we no longer have that denominator. And what do we have over here?
3x times 8.
Well, what is 3x times 8? 24x, right? Might as well multiply. Can you all multiply in any order you want? Can the 3 be multiplied, because there's an invisible multiplication dot there. Can the 3 be multiplied times the 8 first? Sure. Multiplication allows you to multiply in any order, so 3 times 8 is 24, and then the x doesn't have anything else to be multiplied by, so it just gets multiplied by the 24. And now what would we do?
Divide 24.
Divide both sides by
24.
24, so I'm going to come up here. 24x divided by 24, 96 divided by 24. Anybody happen to know how many 24s you can take out of 96? How many, Devin?
4.
4, exactly 4. Okay. Okay, so let's just go back and again say to ourselves, why did we multiply by 3x? What was our reasoning there?
To get it out of the...
To get it out of the denominator, okay? So that was our first goal. We want to rid this problem of that denominator. We want to get rid of that. We want to bring it out. So we multiply, because when you have a denominator, that means it's getting divided by that. So the undoing of dividing is multiplying. Okay, and then we went from there. How about then if we have to solve this one for g? How are we going to get capital G out of that mess? Devin?
Multiply by r.
Yeah, we're going to do the same thing. We're going to deal with the fact that we got this denominator there. So we're going to multiply both sides times r, little r. Notice there's a capital M and a little m, right? Remember how I said that was going to happen? Andrew? Okay, first of all, I'm going to write it like this first, so I'm ready to do that, okay? I want to see what it looks like without anything in it. Okay, now what do you want me to do?
Divide big M little m by big M little m.
Okay, divide both sides by mm,
Yeah.
right? Divide both sides by mm. So little r, capital F is going to get divided by capital M, little m. And the other side is going to get divided by capital M, little m also. And these guys are going to cancel, because there's no subtraction or addition, so we get to do that, right?
Right.
Okay. And then we rewrite it. Capital G is by itself. Is that what we wanted by itself?
Yes.
Oh, good. Oh, I was hoping we didn't go through all that for it. Because there's 5 variables involved in this, so make sure you're solving for the right one. Right? Okay, questions? So again, what you just have to say to your brain, you know how to solve equations. You have to undo what's happening to get the variable alone, and you just have to do legitimate stuff. And then you're gonna get these funny looking answers, but it's okay. What can't you have also, did I say in your answers? A fraction
Inside of the
instead of a fraction. You can't have a fraction within a fraction. No, that's not an answer. That needs simplifying, okay? Okay, everybody needs a sheet of loose leaf paper out, if you would get that out, please.